One thing that is quite common in running systems that is difficult to distinguish from malware is installing new software in the computer. This happens for regular users, and it happens especially for programmers, where we are all the time downloading code and libraries from the internet and incorporating them as part of our programs and running them as they are. So how, as programmers, do you know that you can trust a library? Because you want to add library imports into your applications all the time. In fact, in the last year or two, there was an attack on the XZ library that is widely used in many applications to deal with compression and decompression of data. And some attackers attempted very gradually to add pieces of malware into the source code of XZ, just through GitHub pull requests and such. Fortunately, package repositories that give you libraries have various mechanisms to try to detect and prevent attacks and backdoors. And one of these mechanisms did eventually detect the attempt to modify XZ, and it was blocked. In other words, as programmers, we are often relying on package repositories to have some safeguards in place so that we can trust the package that we give from those repositories. Sometimes that trust is misplaced, and we need to be more careful, and sometimes there are good systems in place to help prevent problems. Geeks is a package manager that takes a particularly direct approach to this problem. The current version of Geeks relies on a relatively small implementation of a relatively small language called Scheme, and an experimental version of Geeks managed to boil that even further. An even smaller Scheme interpreter that is written in C. You still need to compile that C program to get the Scheme interpreter, but they also have a tiny C compiler that's implemented in Scheme. So you can start with either of these, hopefully small programs that you might be able to audit in its compiled form or build up in some even better way in the future. And then that gives you a starting point that you can trust all the way through to various implementations of C until you get to modern GCC, which you can compile all the rest of the packages that are in Geeks. The get-like hashing part is to make sure that all the pieces that you're using in this chain are the ones that you intended to be used and that have been vetted as much as possible along the way, or when a problem is discovered, can become distrusted, effectively revoking the trust in that library so that others will know to switch implementations. So Geeks' bootstrapping process is directly aimed at the problem that Ken Thompson was talking about in Reflections on Trusting Trust.